Hello. Welcome back to the stream. Last time we left here while I was creating the Redis factory. So the thing I was doing was using the Redis options and creating a client for that. Something like that. Let's continue that. So what I did was I created a Redis factory. First, let me just silence my phone. Let's continue now. So I created a Redis factory, I checked the error. Now what we'll do is we'll create a Redis queue from that Redis factory that will serve as the default queue. Redis queue. You might be wondering why the AI is again on because I'm working on another project with Go. So that's why it was on. So Redis queue we will create it from Redis factory dot new. And the name should be, let's name it the um, let's also ask this from the options. Okay. Um, where did it? Default queue name is the name of default queue created at server start. So I'll create a default queue name that will be a string. I'll have to normalize it. Also, if default queue name is empty, it will be named default. So it will be named default. And let's set that out. If ops dot default queue name equals to empty string, then we will name it um, ops dot default queue name equals to default. And that's all we need. Let's pass it along. Default queue name. And that's all. If error if not equal nil, what I will return is return nil and an fmt dot error f. The error should be like create Redis queue. That's all. Let's take the pattern from above and percent w pass along the error. That's all. We have a Redis factory, a Redis queue. Now we will create a Redis DLQ. For a DLQ, one thing I need to consider is for now let's go for the Redis DLQ, comma error equals to Redis. Um, sorry, it was DLQ, not new Redis DLQ. The client will pass along the client, and that's all we need, I think. Yep. If return nil and sorry, fmt.errorf, the error will be create Redis DLQ assign w and the error. So it's done. Next thing, we need to create a job store. We need to assign the values. Job store, values from here to here. Job store equals Redis store. Main queue, Redis queue. What are the other? DLQ store, DLQ store, Redis DLQ, and our factory, Q factory, Redis factory, and that's done. And we need a else part for this that will work for our, what we call it, memory based interface. So memory factory equals to memory factory, q dot memory factory, shouldn't q dot memory factory, and call it here missing argument registration struct q dot new memory factory. Yep, that was the function, and that's how we create a memory factory. Now we have a memory factory, we can create a memory queue. Memory queue, and that will be memory factory dot new, and the name is default queue name, and that's all we need. And if one thing more, it gives out an error if if error not equal nil, return fmt.errorf. The error should be like create memory queue, and that will be err, and I need to pass along here percent w. That's it. Next thing, we need to initiate a job store equals to internal job.new memory store, and the TTL will be ops.ttl, time dot duration into time dot minute, just like we did above. And that's it. Next, we need to initiate the main queue, that would be our memory queue, and the queue factory, that will be our queue factory. That's it. Okay, let's create a queue manager. To manage all the queues, queue dot new queue manager. Okay, we have a new queue manager. Okay, we will register a queue if error in queue manager dot register. Our queue is main queue, and it will give out an error if there is an error not equals to nil, sorry, nil. Then we will say return nil fmt.errorf, and that would be like something like what should be register default queue, register default queue percent w. I need this library implementation to be finished ASAP, because I'm using it in another project I'm creating right now. So I need this to be ready by today. So that's why I'm not explaining much. Registry, we'll create a queue registry. Sorry, a new registry, that would be handler registry, internal handler dot new registry. So we have a handler registry. We also need a retry engine. That will be retry dot new retry engine. Firstly, we need to pass along the store, job store, Max delay will be our time dot duration, so will be from ops dot max retry delay. And what's the issue? Max retry delay caps the retry backup not in okay. Max retry delay a DLQ store. And that's it. I think I don't need more than this. Um, Coming back to this one thing, client owns client. Owns client is not being used here. That's the issue. We need to check if it is owns one thing. We need to pass along. We need to have some Redis client, Redis dot universal client, and owns Redis, something like that, which will be a boot. We need to have some variables like these. We need to use them here. Redis client equals to client and owns Redis, owns client, owns Redis equals to owns client. Okay, and that will work fine. Everything is looking good to me for now. Next thing I need to do is create the retry engine. After creating the retry engine, I need to create a worker pool. Worker pool. That will be like, let me first check how we created everything in our. We also need to create a Snowflake ID generator. Don't we need it? We can create it using snowflake.new one. Okay, a queue manager, a handler registry. We need to register the events which will be registered by our handler by part. So not to worry about that. Retry engine, we need the retry engine that's done. Worker pool, we need to create it now. Then we created the API server, and that's all we need to create. So let me just create the worker pool. So the worker pool will be worker dot new worker pool. It will need a parent context that is ctx context dot background, and store will be Java store. It will need a registry, so that would be registry. Next, it will need a retry engine that's created above. Next, it will need a num workers, that will be ops dot num workers. Then I think that's all we need. Okay, that's all we need. And since worker code is created, we have to use it later. Now coming to the router, new router. We need to create a new function to create a new router. Okay. Okay. We will create a new router just like the things we created in the server. We will not use the server like this. This will only be used by the what do we call it? Binary, but we will create a short implementation of our server here. So let me create a new router function for new router. So what it will do is it will take the parameters that will be stored. Internal job dot store and will be there. Other things it will have is, let's just map like this and this, and now let's do it from here. Store, it will need a queue manager just like we use in our server. Let me show you the server implementation fastly. if I can, yep, this in a store, a queue manager, ID generator, DLQ store, and queue factory. We don't need the registrar because the registrar will be like, what is the registrar? Q.registrar. We will need the registrar if I'm not wrong. Let's see how the things goes, and let's create it. We also need a registrar. Yep, we need a registrar. That is the worker pool, if I'm not wrong. Yep. So I'll pass along the registrar too before creating this. Let's create it. Star queue manager queue manager. So it will be a struct pointer to the queue manager. Now I will create a Snowflake ID generator. Then I will create a DLQ store and queue factory. Queue manager. Let's have the ID generator here. That will be pointed to our Snowflake ID generator. Snowflake snowflake, and next one need is a DLQ store, which will be DLQ dot DLQ interface. Next we need the queue factory, that will be queue dot factory, and lastly we need a registrar. That will be our queue dot queue dot registrar, and that's all we need. What it will pass along after completion, it will give us a http dot handler. So it will give us a handler. We can use that handler in our implementations. So let me create this. Now coming back to the router, I will use a g dot new router, and handler equals to handlers dot new. What the handler need is a store, if I'm not wrong. One thing, I need to create a handler interface first, because I'm not using the internal handler interface, I'm using the external handler interface. Okay, then let me create the internal handler interface. That's a small task. Type handler is an interface that gives us a function handle, and that takes context. And a job. Let's call it internal job. And that looks good to me. That's looking good to me. And let's write the documentation. Handler processes job of registered type. Handle runs the job, returns error. That was I was missing. And the job should be retried or failed. That's all but handle this. Now we'll create a handler function which adapts a function into a handler. So it adapts a function into a handler. Type handler function. So what it will do is it will be a function. Sorry for that. Okay. So it will be a function that will take a context and a job that will be star internal job and give out an error, and that's all we need. Okay, it's a type. And let's also define the function, handle function. Handle runs f for function context job. Func. Wait a second, guys. Sorry for that. So func that will take a handler function handle that will take a ctx context and a job that is internal job dot job and a pointer to that. It will give out an error and it will return out return f. So we are passing the context and the job to the handler function. Okay. We also need a adapter to adapt the handler. So let me write that up. Type. We don't need to export it. Instruct that has a handler. It will create a func a on handler adapter handle ctx and job, and will be internal job I think I have done something wrong. I also need to define a job interface. I can't use the internal job interface here. That only should be used inside the handler adapter. Job.go. Let's define that too. Here we will define the job, how the job looks. Let me turn on AI for this one because this is just struct definition, which is already defined. We only need to add some what we call as documentation. So let me get this from here. This one thing we need to expose it from here. Status defines current life cycle of the life cycle status of the job. Okay, status pending. Job is waiting to be processed. Job has processed to has failed to process. Then next we need to define the job struct. That is also defined here. This is our job struct. We need to copy this. One thing I need to remove is this part. I think. Oh no. No, I don't want to. I just need to import this. Okay, that's it. So what we are going to do is that's right. Hmm. Okay, higher priority will be processed first. That's correct. That's why I was not writing something because documentation, yeah, I can write good. I just need to check it once, and that's all we need. So what we are going to do here is we are working on an internal job interface, and we are going to convert into the interface from above, which are both same, but we want to concern the binary and our library implementation differently. So I will write a simple function that will be wrap job. That will be job star internal job dot job, and I think AI can do this. So internal job is like this. And that's we need. One thing we need, job equal nil, return nil. And everything looks good to me. I need to change the handler implementation a little bit. Here we will not use this. We'll use star job, and in the handler implementation, only the last one will be using the and wrap job, and that's all we need. That's then from this part. Here we need a handler. Handlers.new. So handlers.new. This is a different handler we need to use, and we need to import it to handlers. Now where's that internal API handlers? Where's the end? We need a job store. We need a queue manager. This is working good, but why is the one question I have is Control F. I need it's only being used here and here, so it should work fine. But there is no suggestions, so that's what concerning me. No issues. We'll see through it later. But for now, we need to add the routes we had in our server. That will be these. And Control V. Instead of R, we will use router. And that's all we need. And lastly, we'll return the router. Now we can use the router here. New router, job store, queue manager. ID generator will be Snowflake dot new with the ID 1, and that will be worker pool, and we have a router here. Now since we have a router, what we need to do is we need to create a server. Return ampersand server. Let me check the implementation. ADDR handler is router, worker pool given, handlers given, Redis client given, owns Redis client given, and nil for the app. And that's all we need here. From HTTP we need to import. I think this is done. We need to create now some functions that will be exposed. Like first we need to create a wait a second. So we need to create a register function, so that will bind the job type to a handler. That will be on our server. So it will be job type and handler. That's correct. And This is enough. First, we need to check before doing this if server equals to nil. Not this, we will use task q like this. That will define from where the error came. If strings dot trim space job typing and handler is nil, then we will do this and this s dot handlers dot register job type and an handler adapter that will have handler as handler, and we need to return nil. Why are we don't need to return here, bro. No, it's on range string return nil, and we need to import it. So that's done. Register is done. Now we need to create a register func. Yep, this one. Register func, job type, handler function. One thing we need to check if handler done. Next we need to create a start function. Starts the worker pool. And blocks while the HTTP server is running. Nice. Start error if s equal nil. Okay, this one. Next we'll do is mublock. We'll check if s dot stopped. Okay. If there is no s dot worker started, then we'll do this worker pool dot start and worker pool started equals to true, and then we will unlock the mutex. Listen and serve if errors dot is, this is the error, and we will do this http error server closed. We don't need to return this error equals to this. Now if, and lastly we return nil. And before doing this we need to also call stop the server here. Also call return, instead of return what we'll do is we will have this s dot stop, and we don't return anything here and return err. If error is nil, it will be returned nil. If error is something else, it will be returned like this. And now we need to stop gracefully shutdown. Okay, we need to create a server stop method as mutex lock defer. We don't need to defer, we will close it ourselves. The thing is, if s dot start, then we will do it mutex unlock, and we don't need to return error, we return nil. No issues if it is already stopped. If not, s dot stop equals true, and s dot worker started. S dot worker started equals false, and then we will unlock the mutex. Next, context. We'll create a context with cancel function, and it will be a context dot timeout. And let's define a shutdown time. Hmm. 5 seconds is enough. We'll just remove it from here and use shutdown timeout here. Okay, and then we will do something like var stop error if error in HTTP server dot shutdown. Okay, error not equals to nil, and we need to check if error not error is no, this one not, we don't need to check this, we need to check if error is not equals to HTTP dot error server closed. Then stop error equals stop error dot join. Well, the join, how we use it, it is you like error dot join. And instead of this, we will use simply stop error, and the error we need to pass along. And we need to use errors here, if I remember correctly, errors.join. Yep, this is the right syntax. If worker started, s dot worker pool dot stop, and now here we will check if s dot redis client, if it owns the redis client and the redis client is not equals to nil. If error in s dot redis client dot close, then stop errors. We'll use errors dot join and just pass along the error we came from. And lastly, we will return stop error. If it is nil, then it's good. If it's not, then it's the issue. And we are using the stop function gracefully here. And I think everything is done here. The library implementation, I think, is done. Now I can use the library. For that, let me just write the main package with an example file to tell how to use the package. So example main.go, that will be package, main. Let's create a type. Let's create two types of job. First, email type job, two subject body, that looks good, or two subject body, that good, like good looking. Okay, no issues. Okay, type email handler struct, that will have a from address, and that will be a string. So let's define struct handlers are useful Hmm, when the handler has dependencies that such as a mailer, mm, database client, logger, or domain service. Plus, that's all we need here. So we defined a handler. We will also define a case where the handler does not have dependencies. So let me create func h, that will be our email handler. It will have a handle function like this. Var payload email payload json.unmarshal and return error if error in this error not equals to nil, return err. Next we'll have a select statement, case context.done, return context.error, and the default case will be sending email from this to this with subject this and body this from address payload this return it. And that's all. So it's a type of a handler function that is just a mock function to tell how to use the library. So this is how our library will be imported, and that's we need. Next thing we need to do is create another function or another type. Report payload struct. Let's have account ID, and let's also have a format string, and lastly let's also have requested string, and this is just a report handler. Let's create a function main, func main. So this time we are showing if the payload does not have any dependencies. Server err equals to taskq.new server with the taskq.new, that will be new, and here we will pass along taskq.options. The option struct will be filled like ADDR 80,000 8080 now workers, something like 2 max retry delay, not 10 to 10 per second, that will be 2 or 30 second, 30 or light. Okay, no issues, we'll use this. It's just what we call as. Let's also have to use Redis pass configuration directly. That will be use Redis equals to true and Redis URL is something like how I write the Redis URL, that I have to check from options how the Redis URL is being used. Redis URL, that's right, and that's all. So we create a server. If and why is that? If aeronautical to nil, then we will do log.fatal_f and this. Let's import the log. And that's all we need to import. Next, we need to use the two patterns. Pattern 1, that is register a struct handler, a struct that implements task q.handler. If error in server.register email handler from notification .xyz.com. So this will be how we register the handler in first way. Aeronautical to nil, then we will have a log fatal app. Second will be our pattern 2, register function with pattern 2, register function using task queue handler function. So report handler will be a function. Let's have something like if error in server dot register func, we will need to register the func. The dog type will be, let's say, report dot generate, something like this. This is the example file. So func context job this, and we need to have our payload, report payload. Then with this we do this generating report. Case, we don't need case here. We also don't need this. I think I need to do like log dot printf generating report for this, return that, and this is all. Okay, and aeronautical to nil. Okay, and next we'll create error channel, make channel error 1 of type error. We'll create a go function that will use error ch server.start and call that ctx stop. Let's have with, not with timeout, we need notify context, and the context we need to notify is interrupt. So let's quick fix, import this, not so import context. I think package context has been imported, and it's not in package context, it was in package signal. If I, yep, this was in signal, that was the issue. So we created a context with the first stop, and now we will have a select case. Case something like context dot done, shutting down server, or not like this. Context.done if error in server.stop, error log the fail to stop the server, and this is looking good. If error in error channel, error not equal to log.filter as server error. This one thing we need to check it. If error not equal to nil, then only we will have this, and remove this. And I think this is a good example, to be honest. One thing we need to do here is Q factory, self-assignment of a Q factory. And not like this, we don't need the Q factory like this, that will be memory factory. And DLQ store, we don't have a DLQ store about this. And that's how our library implementation is done. Now you can use the GoTaskQ library. If you have any bugs, report them to the issues section in the GitHub. I'll check through them. If you are available to solve any bugs, you are welcome to solve those. Everyone is welcome to do whatever they can. And with that, I'll sign off. So, no stream from today onward. And I'm busy in another project. I'll update task queue slowly but surely. No issues with that. Okay, thanks for watching. Bye bye.